I think there are two important principles we have to hold on to. First, parents do deserve to know what their kids are learning. And I've got some resources I'll show you about that. Secondly, this issue of how do I help my student, I think that's a very valid concern on the part of parents. And what that means is you should be thinking about what homework you send home with kids and what it is you get them to do. So there are some very interesting things you might do in the classroom which are quite difficult to pull off, which require the expertise of you as teachers to pull off. Those might not be the same activities you send home with children to do with their parents. So I think the parent role is important. So I don't want to underemphasize exactly the shifts in the Common Core, that they will put demands on students, but I also think we want to try and make that transition easier for parents. And so part of the answer to the first one is to make sure that there are some activities that students are doing that look familiar to the parents. And I'm going to point out the standards have plenty of backing for that. There are plenty of things that you can do. Now, this one about helping Algebra 1 students, I think that the whole question was about, it's more of a technical question, which is if you have students who are in Algebra 1 in 8th grade and they're going to be going into Common Core Algebra 1 in high school, I think that's a school implementation issue. It seems to me there are always going to be, when you shift standards, a disjunction. There are students who are going to be caught in that shift, and they're either going to be leaping over things that they shouldn't have leapt over, or they're going to be doing things together. So that's part of the problem there. That said, I do think that the algebra standards in high school do revisit a lot of the algebra that students learned in 8th grade in greater depth. But I don't have a good answer for that, because it seems to me you need an analysis of exactly what was in that 8th grade Algebra 1 course, which I assume was the previous one they had before. Is that correct? And possibly if that duplicates too much of what's in the Common Core Algebra 1, there should be an accommodation for those students. I don't have a good answer for that. That seems to me, in some sense, I guess what I'm saying is that's your problem, not mine. Implementation of standards, especially when you've raised standards, is always going to create places where there's an awkward fit. I mean, the right way to implement new standards, ideally, is to implement them over a 12-year period, where kindergarten, first grade, second grade get rolled in year after year, so that no child has to suddenly do that shift. But we never do anything slowly, and so that's a problem. I think I've already addressed the third point. I think we need to be, now not all different parents have different levels of mathematical understanding, but a mathematically knowledgeable parent, I think, should be able to help their child, and I think that's an important principle. So I would almost put that question on the practice at the school as to what is it that you're sending home with kids. So I'm sure all of you have seen all these viral Facebook problems. I don't know, does everybody know what I'm talking about? Do some people know what I'm talking about? Like where some kid brings some problem home from school and the parent thinks it's stupid, and instead of going and talking to the teacher, the parent puts it on Facebook and then the whole world knows all about it. Some of these problems are stupid. Some of them are not stupid, but it does take some, it's not immediately obvious what the purpose of the problem is. Some of them are perfectly fine, so they're all over the place. But that's something to think about, I think, is what do you send home? This is really, I think, maybe the same thing as the fourth point, too. Okay, I want to say a little bit about this question of how do the standards, and I'm going to come back later on to sort of back some of this up, but I wanted to get these questions out there first. In fact, I'll come to the whole business of acceleration in a few slides, so let me skip that one for now. ELLs, there is work being done now on that. I mean, I think that is true that if you have math standards that require students to explain what they're doing, and to understand what they're doing, then that does increase the language demand. Of course, that language demand has always been there in other courses. I don't have a great answer for that, except that, again, it's an issue of thinking about implementation. And there are, I know, people doing that. The Council of Great City Schools has a project that it's just starting up exactly targeted at the English language arts and the math standards combined, and at thinking about disadvantaged students, ELLs, struggling students, all the groups for whom this increased demand is going to put more strain on them. And I'll come back to that question also when I get to the business about acceleration, because partly there's a misconception here that the standards somehow have now made us want everyone to be in lockstep through the grades, which I think we need to talk about a bit. Okay, this last bullet about there being a lack of focus on math facts is actually false. So I think it's important that you know that. It's the opposite of the truth. The math standards, the Common Core math, I mean, it depends on what your state standards were before, but for most states, the Common Core has a greater demand of math facts and of students learning the standard algorithm than that state's standards had before. And I'll say a little bit more about that too. So that is purely and simply a misconception. And the same goes for the whole dumbing down thing. That's a lot of rhetoric going around about that. But I'll discuss that also when I get to this business of the calculus sequence and so on. So I think what I'll do, were there any other questions that people thought of while we were going through these questions? Yes?
How are the lower grade teachers, it seems to require a lot more content understanding from the teachers as well.
Mm-hmm.
How are they receiving like greater training in terms of just the concepts of numbers?
Well, they're not receiving enough. So the question is, how are lower grades teachers receiving greater training? And I think that's a big failure of implementation of the standards so far, that we haven't focused enough on that. The focus has all been on assessment. It's all been on teacher evaluation. The focus should be on maybe backing off on that a little bit and focusing on teacher preparation. That's just my opinion. I don't own the standards. And, you know, I mean, that is what I'm devoting my life to right now. But yes, you've put your finger on a big problem to which I have no solution. So by the way, like, most of this talk is going to be like that. I'm going to be saying, yeah, I don't know. And yeah, that's your problem. All right, so I think I've mentioned these two principles before. There is a resource for parents. There are these PTA guides. I tested this Google search today and it worked. It's not easy to find them if you go to the PTA website, so I recommend the Google search. And they have grade by grade guides, which are pamphlets. There are 2-page versions and 4-page versions, particularly designed for parents. What should I be seeing my kid be able to do? And so I encourage you to use that resource. I think it's a well-written resource. And then I think I've already made this point about don't send complex classroom activities home as homework. I think I've addressed a lot of these misconceptions, but let me go through them because it does answer some of the questions that I put off earlier on. I guess I should have said, was there anybody else who had another question? So the standards don't tell you how to teach. This is really important. You will hear a lot of people talking about the Common Core curriculum. You'll hear them talking about the Common Core way of teaching. This touches on a point I made earlier. The Common Core state standards are only standards. They're statements of what we as a society think kids should know and be able to do at the end of each grade level and at the end of each high school course. Or at least the high school standards are not arrangement courses, but that's maybe a side issue. They don't tell you how to get there. Now, they do set a high bar. And so it certainly is true that we'll probably have to start doing things differently in order to reach that high bar. But the standards don't tell you that you should adopt a reformed teaching style or a traditional teaching style. I think a lot of people have thought about the issues of the demand on reasoning and understanding, which I'll get to in a minute. A lot of people, I think, believe in their hearts that that demands a reformed teaching style, and I might agree with you, but that's me. That's not the standards. The standards, if you're someone who believes very firmly in a traditional way of teaching, the standards aren't against you. They're just telling you how you have to use that to get there. And so that's an issue. Really what the standards do is they help us resolve some of these debates about the best way of teaching. By setting a fixed standard, we can actually start to compare different teaching styles. Of course, people have been doing research on that for years, but they're always hampered a little bit by the variation in the subject matter itself. So by holding that constant, I think the standards give us some ability to answer some of the controversies about how to teach. The things that kids have to learn are facts, skills, concepts, and applications of mathematics. They don't emphasize one over the other. They balance all of those things. And this idea that the standards underemphasize memorization and skills or underemphasize applications or understanding, they really find a balance between a lot of the different competing views of that in the curriculum. In particular, well, I have a slide later on which shows some of the explicit fluency demands in the standards, and also some of the explicit understanding requirements, some of the applications, and so on. The whole business about dumbing down the curriculum, can my students still take calculus, what do I do about gifted students? The standards are also silent on that issue. There have always been acceleration schemes. I would say the only difference with the standards is that because they're designed to be a coherent progression that fits together over grade levels, you're damaging the students if you skip a grade level. So if you have an acceleration scheme for students, it has to involve compressing what they learn, not skipping what they learn. But there will always be students who are capable of doing that. The issue of calculus, the standards, like most standards, go up through Algebra 2. There were some state standards before the standards which had calculus standards, but we've always had a de facto calculus standard in this country, and that's the AP curriculum. That hasn't gone away. And nothing has changed with regard to that. Students who want to get to calculus in high school will have to probably do some form of acceleration. That was true before. That's still true now. The concern about calculus sometimes comes with people conflating what I think are two different things: college readiness and readiness for STEM majors. Not all students going to college are going to take physics or engineering or biology. Some are. Students who are going into those STEM majors should take more mathematics than is in the Common Core. That's always been true. It was true before. It's true now. The Common Core didn't change any of that. Some people think that every student should take calculus. School districts and states are completely free under the Common Core to require calculus as a graduation requirement if they want to. But the definition of college readiness that we adopted was not STEM readiness. It was readiness for credit-bearing courses in college. Okay, this business about drawings, which is actually, I misunderstood your point earlier about the visual complexity of the textbooks. I think that seems to be more a matter of the textbooks, and well, I don't control them either. There are a lot of textbooks out there. I don't think there are many textbooks out there that are truly Common Core aligned. There are a lot of textbooks that are claiming to be. A lot of the problems with textbooks are problems that have existed before. Sometimes I think people think it's the Common Core, where it's just, well, yeah, it's a problem that's always been there. Hopefully the Common Core will provide publishers with a framework to produce more coherent textbooks. I want to address this issue of drawings, which is, if you've read a lot of the blogs, you'll know that a lot of people are unhappy about that. One of the things they complain about the homework problems that students bring home is that they're required to draw diagrams for everything. There are standards that require students to explain their reasoning, possibly using diagrams, possibly using equations. But in the standards, there really is a progression from that to eventual fluency with the algorithms. And then I put this, no one actually brought this one up, but you'll hear people say the Common Core allows students to have incorrect answers because it only matters really how they got there. It doesn't matter what the answer is, and it's just not true. So now, what I have for the rest of the talk is a series of slides which is more or less just elaborating some of the points I made. And I'm happy to go there, to these slides. But as I said before, I also think that this might be better as a dialogue. We've talked a little bit about some of your initial concerns about that you've heard from parents. So I'd like to take another opportunity to get a little bit of some questions from the audience about concerns you have yourself, or just things that you don't know about the standards, or areas where you have questions about them. And if nobody responds, I'll go through this long, boring series of slides. Yes?
I'm just curious about the alignment to Smarter Balanced Math Assessment and what you've done.
Well, the Smarter Balanced Assessment Consortium and the Park Assessment Consortium, but I guess California is a Smarter Balanced state, so you only care about Smarter Balanced, are completely aligned to the standards. I mean, they're designed to be. The organization that I work for, Illustrative Mathematics, is actually doing a lot of work with Smarter Balanced to help them keep that alignment. Yes?
There's some transitional skills that are coming through. We have additional skills at our grade level. Is that kind of being factored into Smarter Balanced?
Can you tell me a little bit more about what you mean by additional skills? What grade level are you talking about?
Sixth grade.
Sixth
And
grade.
we have the new fluencies that the kids have to master, which are multi-digit decimal operations, which haven't really been hit in previous years that heavily.
Yeah.
So we found we're having to pack it in this year, and then we're kind of taking the place of other standards we need to hit because we really want to get it.
Right. So there will definitely be in the assessment. Yes. I mean.
No gap time.
Well, okay. Now that I don't know. I mean, that's more so. I don't think either of the assessment consortia have yet figured out how they do this phase in and how they handle the problem that initially students will do very poorly on the assessments because they're higher. I hope that they are wise about that. And it's really also a matter of states making wise decisions and school districts making wise decisions about that. But because the assessments are designed to fit the standards, there will be some assessment of those skills. Yes, no. While we're on the subject of fluencies, let me just skip ahead. These are the explicit fluency requirements in the standards. So for whoever it was who had the parent worrying about the lack of fluency, you have kids are supposed to know their addition facts, their multiplication facts. The standard says they should know from memory their multiplication facts by the end of grade 3. I don't think you will find many previous state standards that had such an explicit requirement. Knowing from memory is not the same thing as memorizing. Yes?
There's been some confusion back and forth around addition and subtraction within 1,000.
Yeah.
So are you saying to 9,999?
Yes. Actually, that's in the glossary of the standards. If you go to corestandards.org and download the PDF, there's a glossary. It doesn't often show up in state documents, but it means that the sum ands and the sum are all three-digit number, less than 1,000. Okay, sorry, I misunderstood the question.
That's been the confusion. Do the children, and I teach third grade, so this is the question, is the expectation that their answers could be as high as 9,999, or is it 999? What is within 1,000?
It means less than 1,000. Yes, yes. Yes, yeah. Within 1,000 means they're all three-digit numbers or fewer, three or fewer digits. Yep. Yeah, and you can point to the glossary. I think it says that. I hope it says it clearly enough. Yes. Yeah. Well, this was one of those little pieces of wording that we were pretty careful about. If you tell people to memorize something, I think you're dictating pedagogy. Because you might come to know something very fluently, but without ever having memorized it. And people, I think some theories of pedagogy think that the best way to get kids to learn their multiplication facts is to just have them repeatedly be in situations where they have to know 6 times 7 or whatever, and eventually they will come to have those to automaticity. That's different from saying recite the times tables. So by the end, they ought to by the end of grade 3 have that fluency and have that automaticity, or actually automaticity is a bad word. But anyway, I mean, it's a loaded word that lots of people have different meanings attached to. But they ought to be fluent, fast and accurate with their math facts, but how you get there is up to you. And this is sort of goes back to this point I was saying, and you know, about not dictating pedagogy. So that's what I meant by that. Yes.
As we work with explaining our thinking and different approaches to problems, and kids start experimenting with it, we just keep running into, they know the answer, so especially the kids who get it really fast,
Mm-hmm.
have 10,000 different ways to get there, but none of them really relate to the problem.
Well, I mean, if they have 10,000 different ways to get there, I guess that's okay, right? I mean, they could explain one of them.
But it doesn't model the problem necessarily.
You know, that's my attitude would be fairly lenient with that, actually. I mean, I'm not worried about the kids who have 10,000 different ways to get there, and I guess it seems to me if you tell them that if you say they have to do it in a way that models the problem, or if you have a particular way you want to do it, you're sort of disrespecting their skill. So I guess my attitude would be, I mean, like these are the kids who have that. Now, that said, I think, of course, you sometimes have students who appear to have a very fluent knowledge, but it's a bit fragile. You know, you can give them a question phrased in slightly a different way, and suddenly they can't do it anymore. So there is, of course, there is surface fluency, and there's fluency which is really anchored in understanding. And I think it can be difficult to diagnose that. And so sometimes you want a repertoire of different questions to ask to get at that. Speaking of understanding, so these are all the fluency requirements. Fluency with the standard algorithm. The operations on decimals in grade 6 is there. The standards also do explicitly require students to show understanding of the mathematics that they're learning. And so these are some of the understand standards that call for that. And this was a big deal when we were writing the standards. It seems like, to sort of caricature it a little bit crudely, the world was divided into 2 camps. The people who thought that fluency was most important, the people who thought that understanding was most important, and it's sort of like a false dichotomy. You need both. Standards don't say which of those should come first, but they do require, in the end, students show both. And then this is just a list of some this is really a high school list. I mean, eventually you want students to get to a point where they can use the mathematics they're learning. We want them to not only know mathematics, but to use it. And so that's built up throughout the grade levels, but by high school they're expected to do some serious modeling with mathematics and be able to actually use it. Okay, were there any other questions about the nature of the standards themselves? Yes?
So, you go back to the understanding slide.
Yep.
So, can you talk a little bit about the language demands associated with this?
I don't have a slide about that because I don't have a good answer to that. I mean, the fact of the matter is, and this came up in one of the questions, the standards, by demanding understanding, they do increase the language demands of mathematics. That raises the bar for students who are English language learners. The standards also raise the bar for students who are not English language learners. I mean, they're just generally higher standards than most kids have been held to. I think there's a philosophical point here about what do you think the purpose of raising standards is. If you're if you think that raising standards on kids is sort of like a punishment for them, or if your implementation of standards is going to somehow expect them all to get there overnight, if your implementation is not humane, then that's a problem. Good implementation of the standards will recognize that it's going to take us some time to get to that higher bar, including with ELLs. And good implementation would take time and wisdom and money and all the things that we never have in education. But the standards themselves are not causing that problem. They're somehow sort of setting that level as this is where we want to be. I do think every student has a right to be held to high standards. I mean, students in other countries can meet high standards. Our children are no different from those children. And so they have the right to that opportunity to be held to high standards, but that has to be done in a way that respects where we are right now. So it's not really an answer to your question, I get it, but that's all I have. Yeah. Yeah.
First grade math, and we found that it's very helpful to the young children to have sentence frames that help them structure their explanation and introduce vocabulary that helps them explicate what
So
they're trying to show with their
one of the things that I hope, we didn't really do this when we were writing the standards, but we talked about it, is the English language arts standards and the math standards could have had a greater synergy, in the sense that a lot of what's being asked for of students in math is also being asked for them in the English language arts standards. That they should cite evidence from texts they're reading and be able to explain, justify what they're saying based on the text. And really the same is true of mathematics. And so maybe some of the approaches in the English language arts standards for ELLs will be useful in math. And this project that I mentioned from the Council of Great City Schools is going there. Yes?
Could you repeat some of these? Because I don't think we can hear some of these questions.
Yeah.
And I also have one.
Okay, I'll repeat yours. What do I mean by raising standards? Well, the standards basically require more of students at each grade level in terms of their skills and understandings than many states used to require. So, for example, the requirement, just to give a concrete example, it used to be that students would be still working on fluency with multi-digit addition in grades 4 and 5. The standards essentially require that students be done with that in grade 3, because in grade 3, they're supposed to be fluent with 2-digit addition in grade 2, and then fluent with multi-digit addition in grade 3, because in grade 3 you're starting on multiplication. It's time to move on from addition. So there are simply some requirements that are meant to happen earlier in these standards than before. Okay, let me go back to, so I know I'm skipping around here a bit, but I did want to sort of be responsive to people's questions. I'm probably going to stop in about 10 minutes. Is that okay? I know it said 5:30 to 7 apparently on the program, but I am programmed by 30 years of university teaching to stop after an hour. Actually after 50 minutes, but anyway. Let me go back. I'm sure some of you have seen these shifts in the standards, but I think these are really good talking points with parents that sort of boil it down to what's different about the standards. More so than all the stuff about different teaching styles required. Although there were some very good examples of state standards before the Common Core, most state standards and the country as a whole suffered from this mile-wide, inch-deep problem, where there was just lots of stuff going on in every grade level, and things kept being revisited in each subsequent grade levels because you never had time to quite get anything finished in the grade level before. So we tried to rearrange the standards so that you could cover the same amount of material in 12 years, but instead of repeatedly sort of get it coming back to the same thing, you would in each grade level decide this is the goal of this grade level. So I just gave an example of that with grade 2 with addition and subtraction. You're supposed to have that done by grade 3. So that's what we mean by focus. It means in each grade level you pick your battles, so to speak, and you say this is what we have to get done this grade level so that the teacher of the next grade level can build on it. And we want to sort of have more of a certainty that we send the students onto the next grade level with this under their belt. Focus, by narrowing the number of topics per grade level, you give teachers a chance to really focus on what's important. You give them time. So I also think of focus as something that's helpful to teachers. It gives them more time to do fewer things at each grade level. We also tried to build a progressive structure into the standards. So Kathy mentioned the progressions documents. The standards were actually built on progressions documents. The very first thing that we had the work team produce was narrative descriptions of how various different mathematical topics progress over grade levels, with the idea that mathematics should make sense to both the teachers and the students as a story. You should understand why what you're doing in grade 3 leads into grade 4. You should teachers in grade 3 who are teaching about unit fractions should understand how that in grade 4 is going to be how fractions are built up out of unit fractions. They're going to understand how in grade 4 that enables students to add and subtract fractions with like denominators. The grade 4 teacher who is teaching about equivalence of fractions is going to understand how that leads to students to be able to add fractions with unlike denominators in grade 5. So there's a narrative story there of mathematics making sense. That's what we mean by coherence. And then rigor I've talked about a little bit already. That just means balancing all of these fluency, conceptual understanding, and applications of mathematics. And I think those are important shifts for parents to understand, because it's the opposite of the sort of scary message that some of them are getting, that this is all new and difficult and different. The standards, as you go across grade levels, do make sense. They will have the time to focus in each grade level on helping their kid achieve the major work of that grade level. And their children will eventually come to be able to use mathematics. And this slide just lists some of what the focus is. Really, in K through 5, the focus of the standards is arithmetic. First addition and subtraction, then multiplication and division, fractions starting grade 3. In middle school, you move on to proportional relationships and ratios. By the time you get to 8th grade in the Common Core, 8th grade Common Core is a large chunk of Algebra 1, by the way. And I think that's another important thing for parents to know, because some people will say, well, why are we doing grade 8 algebra? Why are we doing 8th grade Common Core instead of Algebra 1? Well, 8th grade Common Core has a lot of what is in Algebra 1. That said, students who want to take high school Algebra 1 in 8th grade, I think school districts should provide that opportunity. I know that some aren't and some are, but... And then I want to mention a little bit about our definition of college and career readiness, to go back to this point about are my students going to be ready for calculus? What about calculus? Is Common Core getting rid of calculus? The answer is no. In fact, the Common Core, by preparing students for calculus better, I think will increase the number of students who are capable of taking calculus in their final year of high school. Everybody in this room who has taught calculus in college knows of students who come in ostensibly having had calculus in high school, but with a really fragile knowledge of that subject because the algebra was rushed for them. And many students start to encounter, when they hit algebra, the fragility of their understanding of arithmetic. And you sort of build this house of cards on ever more fragile foundations because you're rushing through the topics. By providing, so we thought that one of our jobs, one of our mandates, since we were writing these college and career ready standards, was to make sure we built that ramp to algebra starting in kindergarten. So there are standards in elementary school about students understanding how to do flexible how to use the properties of operations to think about addition. Things like thinking of 7 plus 8 as 7 plus 3 plus 5, putting the 3 with the 7 and then adding the 5 to get 15. Having that sort of break apart tens, make tens strategy, using the fact that you can add numbers in any order with any grouping. That really is a rehearsal for algebra. Students who understand that are going to be less confused when they have to start doing the same things with x's and y's and z's when they get to algebra. So there is a steady progression of domains, starting with elementary school, going through into middle school, and then eventually into high school, which is really tries to build this on-ramp to algebra, or what one of my colleagues likes to call a sturdy staircase to algebra. So if the standards are enacted, and if acceleration schemes do not skip grade levels but compress them, then we will have probably more students ready to really take on calculus in high school, not fewer. I think I'm going to stop there. I did want to mention the standards for mathematical practice. That's a really important part of the standards, which is those are standards about how students should do mathematics, how they should think, habits of minds they should have that help them be mathematical practitioners. I've already talked a lot about college and career readiness. I do want to mention, so one of the things you might hear from people is that there was a bit of a mention of this in one of the questions about dumbing down the curriculum or the standards not being as high as the standards of other countries. There was a study done by a Michigan State researcher who studied the alignment, the agreement between the Common Core and standards of high achieving countries such as Singapore, Hong Kong, Korea, and so on. And he found a very high agreement. It was only K through 8, but he found a very high agreement between those Common Core and those countries. And he also compared the Common Core with previous state standards, and he found that the Common Core was closer to the standards of high achieving countries than any of the previous state standards. So that's really a very powerful piece of research. I don't expect you're going to go around citing research to all your parents, but I mean, I think you should know that the standards really are aligned with the best international standards and that they are world-class standards. And let me finish off. I don't know if this comes up. I know in some states that are really concerned about local control, it's a big catch cry. So I think the other thing that's worth knowing in the back of your mind, if you have parents who come in and who are worried that the standards are some sort of federal overreach, they were not developed by the federal government. They were developed by the states through the Council of Chief State School Officers and the National Governors Association. They don't dictate pedagogy. They just set some sort of common level of standards. And that's what local control really is about to me. Let's have an agreement on standards, because that's just a useful thing to have. Just the same reason it's useful to have a railway gauge that doesn't jump across state lines. Having common standards means we can share knowledge across state lines about how to teach kids mathematics. But how you do that locally is up to what you do in your local districts. A lot of the issues that you're having have to do with local implementation. There are good implementations out there and poor implementations. Because we have common standards, we can learn from each other, and the poor ones can get better by seeing how successful the good ones are. So there's really a value in common standards in helping people keep control of their local curriculum. All right, I'm going to stop there, but I'm happy to take more questions for as long as people have them. But I think I'm finished talking. Thanks.